How to build a RAG application on Azure, architecture, tools, and gotchas. Hey, welcome. In this video, we're breaking down how to build a RAG application on Azure, architecture, tools, and gotchas. Let's get into it. Now, let's talk about what is RAG in Azure OpenAI. RAG in Azure OpenAI is an architecture pattern that combines Azure AI Search with Azure OpenAI Service to produce answers grounded in a private document corpus, without fine-tuning the underlying model. A standard GPT-4 deployment knows nothing about your internal data and has a knowledge cutoff. RAG solves this by splitting the problem into two stages. Your documents are chunked, embedded using, and stored as vectors in Azure AI Search. When a user asks a question, the system embeds that query, retrieves the top k semantically similar chunks, and passes them as context in a GPT-4 prompt. The model answers using that grounded context and cites its sources. Understanding where RAG fits in the Azure AI tooling helps before you start building. Our comparison of Azure AI Foundry versus Azure OpenAI Service explains how Foundry adds orchestration, evaluation, and safety tooling on top of the base OpenAI service, which matters for production RAG systems that need quality gates. Now, let's talk about the Azure RAG architecture, core components. A production RAG Azure OpenAI system uses 5 layers working together. If your team writes C#, semantic kernel is the right fit. Microsoft built it for Azure OpenAI RAG C# workflows and it integrates cleanly with Azure Managed Identity, Azure AI Search, and the broader .NET stack. Python teams reach for LangChain or LlamaIndex, both of which have first-class Azure AI Search RAG support. The Azure OpenAI RAG Python quick starts on Microsoft Learn use LangChain for this reason. Teams running Power Automate consulting work should note that neither framework connects to Power Platform natively. You expose the RAG layer as an API and Power Platform consumes it via a custom connector. If your documents sit on-premise or in a hybrid cloud Azure setup, run the ingestion pipeline in VNet integrated compute with ExpressRoute or VPN gateway connecting back to your data center. This pattern is common for teams doing migrate on-premise to Azure projects where sensitive data cannot leave the corporate network yet. An Azure infrastructure assessment early in the project confirms whether your existing network topology supports this or needs re-architecting before ingestion code is written. Let's talk about next up, how to build a RAG application on Azure, 5 steps. The 5 steps to build a RAG app on Azure are: provision and configure core services, build the document ingestion pipeline, implement retrieval and orchestration, wire the generation step with prompt engineering, and deploy with CI/CD and monitoring. Start with an Azure architecture review to confirm your tenant supports private endpoints and that your Azure AD configuration is clean. Create an Azure AI Search resource at standard S1 tier minimum for semantic ranking and an Azure OpenAI deployment with access to end. Store all API keys in Azure Key Vault and use Managed Identity throughout. If you are starting from an Azure landing zone implementation with networking, RBAing, and policies already configured, this step takes 2 to 3 days. Without a landing zone, budget a full week for governance setup before a single document gets ingested. This is consistently where teams underestimate the work. Ingestion requires extracting text from PDFs, DOCX, and HTML, chunking into 512.1024 token segments with 10 to 20% overlap, embedding each chunk via Azure OpenAI, and indexing with metadata including source URL, document date, and access tier. Microsoft's Azure Search OpenAI demo on GitHub is the canonical Azure OpenAI RAG GitHub reference for this pattern. Deploy it as an Azure function or container app that watches blob storage for new uploads and processes them automatically. Let's talk about now, RAG Azure OpenAI gotchas, what most teams discover too late. Most Azure OpenAI RAG tutorials stop at "it works in the notebook." In our experience at Q Services, these are the production failure modes teams encounter most often. Teams default to 1024 token chunks because that is in the documentation. The right chunk size depends on your document type. Dense legal contracts need 256 token chunks to isolate individual clauses. Knowledge base articles work at 512 tokens. Policy documents with long continuous arguments work at 1024. If retrieval quality is poor, chunk size and overlap settings are the first variables to tune before touching the model or prompt. This single change often improves answer faithfulness scores by 20 to 30%. Azure AI Search supports security trimming, store in field per document chunk and filter at query time using the user's Azure AD token. Without it, users retrieve documents they have no business seeing. An Azure security assessment at project start surfaces this requirement before it becomes a breach incident. This is also where Power Platform governance matters. If a Power Platform development company builds connectors to your RAG API, or Power Apps development services teams create flows that call it directly, those clients inherit the security model, or bypass it entirely if enforcement is not at the API layer. Let's talk about next up, how Azure Consulting Services teams structure RAG projects. Q Services is a Microsoft certified solutions partner specializing in Azure, and we have completed 500 plus Azure and Microsoft platform projects since 2014. As a Microsoft Azure consulting company and Azure migration partner for enterprise clients in banking, healthcare, logistics, and SaaS, we have run RAG engagements at every scale. The structure we follow is consistent across sectors. Every RAG engagement begins with an Azure infrastructure assessment. We audit the tenant configuration, data residency requirements, identity model, and network topology before writing any code. Alongside this, we run a full Azure architecture review and an Azure security assessment to confirm that private endpoints, document-level access control, and audit logging are designed in from day one. We also evaluate whether the document storage layer suits a lift and shift to Azure approach or needs to be cloud-native from the start, which affects the ingestion pipeline architecture significantly. The build phase uses Azure DevOps Consulting Services style CI/CD from the first sprint, every component in source control, every deployment behind an approval gate. That aligns with the human-in-the-loop governance principle detailed in our AI agent governance post, ensuring human approval at every deployment stage. We apply the NIST AI risk management framework to enterprise RAG deployments, covering bias controls, robustness requirements, and traceability. We also implement Power Platform governance controls to prevent low-code developers from calling the RAG API without rate limiting or audit logging, a gap that often appears when Power Automate consulting teams build connectors without a security review step. Now, moving on to conclusion. Building a RAG Azure OpenAI system that holds up in production, not just in a proof of concept, is a 10 to 17 week project for most enterprise teams. The gap between demo and production sits in 4 specific areas: chunk size tuning for your document types, document-level security filtering, hybrid search configuration, and ongoing RAG evaluation metrics. The Azure RAG architecture decisions made in week 1, specifically the search tier, access control model, and orchestration framework, determine how much rework you face in month 3. Done right, RAG on Azure gives your organization a secure, auditable AI layer over proprietary knowledge that no public model can replicate. Talk to an Azure AI architect at Q Services. We will start with an Azure infrastructure assessment and Azure architecture review and deliver a production-ready architecture in your hands within 2 weeks.